Ladies and gentlemen, good morning, and thank you for being here. I will present a paper for evaluating CRDT for real-time document editing, written by me, Mrs. Claudia, Mr. Gérald, and Hyun-Gul, and Mr. Pascal Urso is here. In the years 203, Dougherty proposed the term of Web 2.0 to describe a new evolution of the web. Web becomes more collaborative and in real times. So collaborations becomes very critical to be able to contact people at different time and located in different places. Recently, real-time collaboration becomes a major challenge of Google. We often hear about Google Docs and Google Waves. There are several types of collaboration. We can collaborate to edit videos, images, XML file, document file, etc. In our work, we focus on collaborative for document editing, document text. In real time, if application cannot reply quickly to users, user can get frustrated and will be quit applications. Some study found that people can notice bad performance of applications if response exceeded 50 milliseconds. Then performance is a key factor of success of applications in real-time document editing. This pushed us to make study of algorithms in performance. Today, there are several applications for real-time document editing, for example, Google Docs, Etherpad, and Cowork. But these applications are centralized or on local networks. To overcome disadvantage of centralized authority, a tendency is to move to decentralized peer-to-peer collaboration. Then our first goal is we want to decentralized collaboration systems, and for that we need to choose and understand an algorithms, and we evaluate these algorithms in performance. Until now, all algorithms are evaluated in serialized traces, for example, traces of Wikipedia or simulated traces, but never in real traces. Other objective is we want to retrieve real traces, and we run all algorithms in same condition, and we observe behaviors of each algorithms. All algorithms chosen are based on optimistic replications. To obtain higher reactivity, data replication is necessary in real-time document editing. Many mechanisms dealing with data replication have been introduced, but in real-time document editing, optimistic replication is suitable. It gives to user an illusion of work in a single copy, and high availability can be obtained, and we avoid the time of latency. Instead, user send a message to all other replica. User contact directly copy local. When a user make an operation, this operation is executed in local copy, send it to all other replica, and when a replica receives this operation, it executed it in a local copy, remote copy. All algorithms evaluated in our experiment are based on optimistic replication. First approach is operation transformation. This approach takes into account the effects of concurrent operations. When a replica receives an operations, this operation is transformed with concurrent operations. And for this, we need two components. An integration algorithms responsible to receive, diffusion, and integration algorithm operations. We evaluate SOC-TDO algorithms, and we need to some transformation functions. This is an example of transformation functions. For example, when we have two users insert in same time two operations. User one insert, for example, as a position 3, and user to insert character 2 at position 6. After sending a message, if a replica 1 does not take into account the effect of concurrent operation OP1, a replica 1 inserts OP2 at position 6, and document is master 2R instead master 2. It didn't take into account the effect of concurrent operation OP1. Then to have a correctly document, instead insert character 2 at position 7, we insert 2 at instead insert character 2 at position 6, we insert it at position 7. For example, Google Docs use algorithms in this approach, operation transformation algorithm called Jupyter. Operation transformation detects concurrent operations with vector clock, and this solution cannot scale well in cloud and in a peer-to-peer environment. Recently, a new approach called CRDT, Commutative Replicated Data Type, to ensure consistency on peer-to-peer environment, on peer-to-peer networks emerged. Unlike operation transformation, CRDT no require detection of concurrent operations. CRDT is designed for concurrent operation to be natively commutative. In CRDT, document is a linear sequence of elements, and each element has a unique identifier. In this approach, we evaluate algorithms Logoot, RGA, WOOT, WOOT, and WOOT-H. To have a global ED for all algorithms, we make theoretical study. We represent here a time complexity. In worst cases for all algorithms, we consider time complexity for generate operations and the time of integrate remote operations. We denote by H number of operations and R number of replica. For all algorithms, we haven't an algorithm in the absolute the best. We can just say WOOT is the worst in most cases, but not all. Logoot and RGA, it's the best candidate in our experiment. Even though traditionally it's operation transformation algorithm used in this type of applications, for example, SOC2. To evaluate algorithms, we need two real traces. This is an example of real traces. When user make an actions insert, for example, we store a content of this insertion, a position of this insertion, and some other informations for example, timestamp and the unique number of user. When user make an operation delete, we store position of delete, number of character deleted. For example, in line 2, user deletes 30 character. And we store other informations, for example, timestamp, vector quote, etc. Generally, user insert only one character, but sometimes the user can insert a block of character with copy paste. For example, user insert hello world at position 0 with copy paste, insert question mark at position 11, etc. This operation inserted with you. This operation made by user are called user operations. These user operations are transformed with specific algorithms to specific operations called character operations. And these user operations are executed with specific algorithm in the local copy. These specific algorithms transform user operation into one or more specific operations called character operations. For example, insert hello world at position 0 is transformed into insert H at position 0, insert E at position 1, insert L at position 2, etc. Character by character. After that, these character operations are propagated to other replica. When remote replicators save character operations, specific algorithms are executed it in local copy, character per character. In our experiment, we evaluate execution time of user operations and execution time of character operations. To retrieve real traces, we performed some experiment with student. First experiment is report. Was performed with 13 students. We asked 13 students to write their report of semester on a software engineering project master course. And we divided 13 students into 3 groups, 2 groups with 4 students and 1 group with 5 students. Each student in groups work in private computer and was not allowed to use other communications tools. This experiment lasted 1.5 hours. Second experiment is a series performed with 18 students. We asked 18 students to watch an episode of series Big Bang Theory and write collaboratively a transcription of this episode. We divided this 18 students into 9 groups of 2 students, and we asked each groups to write a transcription of heroes, actors, and environment. This experiment lasted 1.5 hours. We redo this experiment twice to have more traces. We make 2 experiments, report and series, to have the most possible cases. Experiment of report is classic experiment, and the number of concurrent operations is smaller. But with the experiment of series, we have more concurrent operations. After retrieve traces, we make some calculation. In this table, we can say we have number of user operation in group 2 is greater than number of operation in group 1. But the number of character operations in group 2 is greater than number of character operations in group 2. Because number of copy-paste in group 2, size of copy-paste in group 2 is greater than copy-paste in group 1. The proportion of delete in experiment series is smaller due to difficulty to student to make correction on their document. Student had less time to make correction on their document. After retrieve traces, we run each algorithm on each log 10 times in same JVM and in same server. In this table, we represent maximum execution time in milliseconds of user operations. If time of response exceeds 50 milliseconds, users can observe bad performance of applications. We can say WOOT H and WOOT O cannot build safety in application for real-time document editing. We have some execution exceed 50 milliseconds. This table, we cannot observe behavior of all algorithms with table. Then we draw a graphic to observe behavior of each algorithm over time. We represent in this graph algorithms behavior for execution time of user operations in group 3. On a logarithmic scale and average operations for 100 operations. For all algorithms degrade over time. But Logoot degrade more slowly than other. This degradation due to size of document and the size of identifier grows over time. Sometimes all algorithm increase. This is due to insert or delete a block of characters. We can also say WOOT and WOOT cannot be safely built into applications for real-time document editing. So his behavior, it will exceed 50 milliseconds probably quickly. We can also notice the same behavior of algorithms RGA and WOOT. Both algorithms are based on hash table. We represent in this graphic algorithms behavior of for execution time for character operations in crypto on logarithmic scale and average operation of 100 operations. Some algorithm remaining stable. We can notice same behavior of family WOOT and between WOOT and WOOT. We have behavior chaotic of SOCT2 due to inefficiency of mechanism garbage collector. Garbage collector is a mechanism for purge history and narrow research of operations and make transformations. SOCT2 cannot build safety in applications for real-time document editing. So his behavior, it will be probably exceed 50 milliseconds very quickly. We represent here algorithms behavior for character operations in Series 2. This behavior is slightly different because the number of operation delayed is smaller. Student had less time to make a correction on their document. We can just notice same behavior of RGA and WOOT. Both algorithms are based on hash table. We can say this is first experiment for evaluate algorithms in performance with real choices, including operation concurrent, and algorithm CRDT suitable for real-time collaborations are suitable for real-time collaborations and is outperform a respective operation transformation approach. In this work, we make a framework where includes all algorithms in this framework, and this framework is open source under GPL license. Our direction in future work is study more criteria of comparison, like communication complexity and memory usage. Include more algorithms in our framework, and retrieve a large size of chances of real-time collaboration. We hope Google to give us real chances. And we extend our experiment and evaluate it for other type of collaborations. Thank you.
We do have a few minutes for questions. Please use the floor mics. So suppose Google was in a position to give you some test data. How much data would you need in order to take the next step in your research, do you think?
A large process, just this.
Well, let me suggest that a megabyte or two would be enough to give you some statistically significant results, wouldn't you think? A megabyte of traces?
Yes.
That's
Yes.
Yes. Do I hear terabytes? Terabytes. Are there any other questions? Very good. Well, thank the speaker one more time.
Thank you.